I swear, every time I lose something, I can't lose. Where did I put that dang pot? And I want to make some tea. Darn it. What can I find? Did you? Oh, hey guys. Sorry about that. I'm Mr. P, by the way. Guys, I can't find my pot, and I'm trying to make some tea today. I don't even know what's going on. We're going to go ahead and spill the tea right now, okay, guys? Because I'm going to teach you today about the remainder and factor theorem. So don't spill the tea yet because I haven't found my teapot. But once I find my teapot, you guys are good, okay? So the remainder and factor theorem, guys, what essentially does is that it makes our lives easier when we're trying to evaluate remainders or find factors of certain polynomials in polynomial division, whether that be long division or whether that be a little simple method that looks like voodoo, but it's not really voodoo, and I like to call it synthetic division. Synthesize your own division. So, as I said before, this is going to make our job a little easier in finding remainders and finding factors in general. Now, I can't find my teapot, but anyways, we'll find it later and we'll spill the tea later about this. Let me just teach you about the remainder and factor theorem, and I'm going to show you guys how it's applied in real life, all right? Remember, also, polynomial arithmetic, adding, subtracting, multiplying, and some division will always help. Now let's spill the tea. All right, guys, so what we know about the remainder theorem. The remainder theorem states that if a polynomial f of x is divided by a binomial of the form x minus a, f of x being the dividend in this case in division, and x minus a being the divisor, which is the binomial, which is the divisor in this case, the remainder is f of a. So after you've seen this and you apply something in math we like to call the zero product property, you will evaluate that into the f of x, which is our dividend in this case, and you will be essentially given a remainder of f of a. Something to illustrate how this works is the formula or general abstract form of how it looks. So f of x being equal to x minus a, which is the divisor, times the quotient, which is the result of the division between f of x and x minus a, plus the remainder that it yields if and only if it does yield a remainder. Now, if it does not yield a remainder, it is a factor of that f of x, the x minus a. But that's something that we're going to talk about a little later when I go ahead and cover the factor theorem. But right now, let's show an example and spill the tea with my non-existent teapot about how the remainder theorem works. Okay. So, we will essentially start with an example of a polynomial of quartic form, 2x to the fourth minus x cubed plus 2x squared minus 6, and we're going to divide that by a little buddy here, x minus 2, which is our binomial of the form x minus a. But before we ever even touch this polynomial quartic form to find what the remainder is, we're going to have to pay attention to our little guy here in the denominator real quick, which is our binomial of the form x minus a. We're going to apply what I essentially mentioned before, something we call the zero product property. You guys might have heard about this when you took Algebra 1, but I'm not sure, and I'm going to review it with you, okay? So, x minus 2, the way that we essentially apply the zero product property to this, we're going to take x minus 2, and we're going to make it equal to 0. We're going to solve for x by adding 2 on both sides, of course. Regular pre-algebra. We're going to head and cancel those 2. And then 0 plus 2 equals 2, meaning that x equals 2. Pay attention to that x equals 2 real quick, guys, because at the end of the day, that x equals 2 is that a in the binomial form that we have been essentially talking about, and the one that we are going to evaluate to our f of x. So let's go ahead and do that to find a remainder. Anyone spill the tea yet? Not sure. We'll take our big boy here in the numerator. 2x to the 4th minus x cubed plus 2x squared minus 6. And we're going to evaluate it at the point of 2, positive 2, which x equals 2 from the zero product property. So we're going to go ahead and say 2 times 2 to the 4th minus 2 cubed plus 2 times 2 squared minus 6. Can't forget that constant term 6, guys. And we're going to go ahead and say 2 to the 4th equals 16. So let's go ahead and drop that real quick and put 2 times 16. So we don't lose ourselves. This is basically following, please excuse my dear Aunt Sally, PEMDAS order operations. Guys, everything plays in here. Yeah, boy, this is a game. So 2 times 16 minus 2 cubed is 8. So it's going to be minus 8. Plus 2 times 2 to the second, or 2 squared essentially. Remember PEMDAS, you got to do that exponent first. 2 squared is 4 times 2 is 8. So that comes 8 as well. And then we can't forget our constant term of minus 6. 2 times 16, 32. Minus 8 plus 8 minus 16. Minus 6, sorry. Excuse me. 32 minus 8 is 24. Plus 8 is 32. Minus 6. We yield a remainder of 26. But Mr. P, that's all cute and all. And we spelled the T, okay? But, okay, cool. We spelled the T. That's very, very good. But, how do we know for sure that 26 is the remainder upon division of 2x4 minus x cubed plus 2x squared minus 6 divided by x minus 2? Well, I'm going to show you through a method that we call synthetic division that this bad boy is the same as our remainder when we divide this by synthetic division. Now, check out this voodoo. Let's not call it voodoo. I'm the next David Copperfield. We're going to do it with magic. The zero product property also holds when we do synthetic division. So, let's do this in green. The way that we synthetically divide a polynomial by a binomial is that we're going to apply the same zero product property, and we're going to take that x equals 2. But we're going to put that little cute x equals 2 in a box. Actually, it's a very good idea to do this in green. We're going to do this in red, so you guys can see it a little bit more visible. And that's better. Cuter, too. So you got your 2 in the box for all my Timberlake fans out there. Now we got 2, so we're going to line up the coefficients of our f of x. Coefficient being the number that's in front of each variable. So number 1, we're going to start with our term of the 4th power, which is 2. Coefficient 2. Now we're going to go ahead and skip ahead to our cubed term, and we got minus x, meaning it's just minus 1 because remember, when we don't see a number in front of that x, we just assume that there's a 1, and since there's a negative sign, it's negative 1. We're going to go ahead and put our next term, coefficient of the next term, which is positive 2. Oh, but we actually notice, guys, number 1, that we are missing an x term. So when we're missing a certain term of the form n minus 1, as we continuously go through the whole terms and the whole powers, what we're going to do if we're missing a term, we're going to put 0 on it. So I put 0. And then, of course, we have to include our constant term of negative 6. We're going to draw a row of numbers, or draw a line for another row of numbers. We're going to drop that 2 like italic, Snoop Doggy Dog. And the way that we do synthetic division is that we're going to essentially multiply in a diagonal manner and add a cross. So 2 times 2 is 4. Negative 1 plus 4 is positive 3. 3 times 2 is 6. 2 plus 6 is 8. 8 times 2 is 16. 0 plus 16 is 16 because of additive inverses. 16 times 2 is 32. And then negative 6 plus 32 is just positive 26. And checked out. We got the same remainder. That proves that a remainder theorem holds in this case. Now, I'm going to show you guys a really, really quick, very, very quick and cool theorem that piggybacks exactly from the remainder theorem. And we like to call it the factory theorem. Go ahead and share my screen and I can show you guys what the factor theorem is. So the factor theorem states that a polynomial f of x has a factor x minus a. Remember that little binomial, which is our divisor. If and only if. So this proves that this only works if and only if this applies, this condition applies. F of a equals 0. So we have a biconditional statement here that if this, it's that. If we have this, we have that, and then we have that, we have this. That's called a biconditional statement, but of course, that's something we're not going to cover up right now. So meaning that x minus a is going to be a factor of the f of x, kind of similar to the example that we did, if and only if the remainder that it yields is 0, or in other cases, it will not yield a remainder. Again, I've also included a Spanish translation to this. It's called el Teorema de Factor Polinomial. Let's go ahead and show another example so I can show you guys how it quickly works. Okay, guys, I'm gonna do some blue. Blue, So we're gonna go ahead and use a simpler example and use a polynomial of quadratic form, only meaning a power of 2, x squared plus 11x plus 30. So we're not missing any terms here. And we're gonna divide that by a binomial of the form x plus 6. So it doesn't look like x minus a, but it's the same idea. Zero product property holds in this as well. Make this equal to 0. X plus 6 equals 0. Subtract by 6 on both sides to solve for x. 0 minus 6 is negative 6. X is equal to negative 6. But, Mr. P, how are we going to show that this is a factor? Are we going to use the same remainder theorem, or are we going to use something different? Well, of course, we can also use the remainder theorem. But do we want to make our lives a little easier and use the remainder theorem and do a long algebraic expression, or do we want to do synthetic division? Well, synthetic division is always quicker, and it's a little easier, and it's also a little neater. Let's do synthetic division. Put that negative 6 again in the box. Line up our coefficients. Coefficient 1, coefficient positive 11, and coefficient 30. Drop down 1 like it's hot. 1 times negative 6 is negative 6. 11 plus negative 6, which is the same thing as saying 11 minus 6, is positive 5. Positive 5 times negative 6 is negative 30. (30 minus 30 is 0, which proves that since this is our remainder, we have a remainder of 0. Therefore, the factor theorem holds in this case. But Mr. P, that's all cute and all like you said before. How do we verify this? Because Mr. P loves to verify as well. So let's go ahead and verify this real quick, as we can see, guys. But we're going to resort to an old algebraic method, very similar to how we resorted to evaluating or using also synthetic division in this case. But we're going to go ahead and be factoring quadratics. Because remember factoring quadratics from algebra 1? I hope you do. We're going to write our dividend, x squared plus 11x plus 30. And we're going to go ahead and factor that quadratic real quick. So how do you factor quadratics, Mr. P? Can you remind me? Of course I can remind you. We're spilling some tea, okay? So what we're going to do is we're going to find two numbers that multiply to give me positive 30, but at the same time, those two numbers that multiply positive 30, it adds to positive 11. Does anybody have a guess? Anyone? Anyone? Bueller? Anyone? No? Nobody? I'm going to teach you guys. Spilling tea. I can't be the only one spilling tea. You will soon find the right combination. Bingo. X plus 6, x plus 5. Positive 6, positive 5. 6 times 5 is 30, but also 6 plus 5 is 11. But we also notice something. This also holds by the zero product property, meaning that we have to solve for 0, and we have to solve what our x's are. x plus 6 equals 0? Easy, we already did that. X plus 6 equals 0 is x equals negative 6. X plus 5 equals 0, same idea. X is equal to negative 5. Did we notice something, guys? Does anybody notice something? That x minus 6, when we also did that x plus 6 equals 0, and we solved it, that x equals negative 6, x equals negative 6, checks, and bingo, we have the correct combination. That negative 6 is what we call a 0 of this polynomial that we see here. And also that the factor theorem holds because obviously this is a factor and it's been verified and proven. Hope that makes any sense to everybody. Because right now we're going to engage in a fun little Kahoot game to test our knowledge. I'm going to go ahead and play Kahoot, guys. Now I'm going to show you how it's done. I'm going to go ahead, host, because I am the host. And we're going to do our little game pin real quick. Let's put some music in here. Holiday cheer. Agustina's in the game. Agustina's in the game. Who is this Rodolfo? Yo, welcome Rodolfo and Agustina to the game. Let's start the game, guys. Let's start the game. Let the games begin. The remainder and factor theorem. What is the correct factor of x squared plus 3x minus 28, guys? Let's go. I know you guys can do it. We got 20 seconds. 20 seconds on the clock. Come on. 20 seconds on the clock. Oh, my goodness. Look at Agustina. She solved it. And it is the correct answer, guys. Of course, it is x plus 7. As we can see here. Let's move on to the next question. Man, Rodolfo, you got to step up your game, man. Let's go ahead and step up our game with Rodolfo real quick here. Question number 2. The remainder theorem states that x minus a is a factor if f of a is equal to 0. Let's see. We got one right and we got one incorrect. Let's see who we got here. Rodolfo Agustina's taking all the points. Man, what are you doing to yourself? Let me see. We're going to go to the next question. All right, guys? Quiz question. What is the remainder in 7x to the 5th minus 4x cubed plus 2x minus 11 upon division by x plus 3? And this Rodolfo kid needs to step his game up because he's not answering the questions. And Agustina is killing it in this game, guys. Let's go ahead and go to the next question, guys. True or false? An x squared plus 11x plus 30 divided by x plus 6. I think it's where it is. Man, oh man. Who's killing it? Agustina's killing it today. Woo! Good job, Agustina. Let's go to the next question, guys. Last and final question. 5 out of 5. This is the Woo! That was fast. Because y'all know that I am all of the above. Woo! Rodolfo comes in second place. But our star winner is Agustina! Woo! Well played, guys. Well played. Okay. So, guys, as you can see, that has been my whole lesson on the remainder of factor theorem. I hope everybody had fun because I know I did, learning about the remainder of factor theorem and playing that fun Kahoot game. Now, if I could only find that. Oh, you look at that. She was here all the time. Hello, Mrs. Potts. Hello, Chip. Looks like we're going to go ahead and spill the tea.